Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at this example from section 2.1, and this is finding average velocities. And what we're going to do is we're going to pick values as we go up that are closer and closer to the value that we want to find our instantaneous velocity at, and then we're going to make a conjecture. A conjecture is our best guess for what the actual instantaneous velocity is at t equals 1. So let's kind of go through the terms real quick. The instantaneous velocity is your speed at exactly this value 1 here. So after 1 second, the instantaneous velocity is exactly how fast you're going. Now, the average velocity means that we're going to find how fast you're going, let's say, at 2 seconds, and then 1 second, and then we're going to find the slope between those two points there. So here's the formula, and this is, you can call it a lot of different things, but this is the slope of the average velocity, which is AVE, so we know that. And we're really going to let our calculator do the work for this one. So let's first put this equation up in our calculator. So that is here. So don't forget, when you start off, don't put a minus sign, put a negative. So that's negative, let me go ahead and put this in again, negative 16x squared, and that's going to be plus 107x. Alright, so that puts our equation right up there. And then what we're going to do is we're going to actually put this formula in here. So we need to call one of these points, either the first or second point of each one of these, the t sub 1, and then the other point t sub 0. And we need to stay consistent. So if we call this value here, the right-hand value, t sub 1, that means we need to call all the right values in these intervals t sub 1. And then that remains 1, which will be our t sub 0. And then we need to, all of our left-hand values will be t sub 0. Alright, so putting this in, it's going to look like this. So let's go back to the calculator here. So always put the entire top and entire bottom of your fraction in parentheses. So let's do the top first. So the top is going to be, we're going to go to vars, y variables, and then function. We're going to put a y1 in there, so we're going to say the y1 evaluated at whichever x value we put in there. So I'll just put a little evaluated at x minus, now the next one would be the y evaluated at our value of 1. So we could actually just put that in there. So if you put a 1 in here, that's going to be 1 squared is 1 times negative 16 is negative 16 plus 107 times 1, which is 107. So it's basically 107 minus 16, which is going to be 91. So we can just put that one right in there, just like that. And then we're going to divide that by, again, this value, the first value, that's going to be x minus 1. Just like this. And what happens is, if we put the 2 in there, it's going to evaluate it at 2 minus the evaluation at 1, all divided by the 2 minus 1. And that way we can check for different values and put it into our table and get these answers really quick. Alright, so the next part is the table, but before I go there, I'm going to do second window. I'm going to make sure, that's your table set, make sure that this is on ask. If it's not highlighted, hit enter. If you don't, you're not going to be able to put in your own values for x. It'll just list out a bunch of values, usually 1 through 10. Alright, now we're going to go to second graph, which is our table. Let's delete what I have in here right now. And now what we're going to do is kind of go back down here. So we have 2, 1.5, 1.1, 1.01, and 1.001. So we just put those values in there. Alright, so 2, oops, wrong button, 2, 1.5, 1.1, 1.01, and 1.001. Alright, so this is what we get here. So we see that the average velocity, which is your Y2 column, because that's where we put that average velocity formula in, starts off with an average velocity of 59 when we're going from 2 to 1, or 1 to 2 more specifically. And then as we go down, we notice that our our slope is going up. It looks like it's getting very, very close to 75. So after putting all of these values in all of these spots here, my conjecture would be that the instantaneous velocity at t is equal to 1 is going to be 75. All right. If you have any questions, please let me know, and have a great rest of your week. Thanks.